let's just move on further towards the next topic, which is nothing but representing root x on the number line. I hope representing any rational number on the number line is all clear to you. Now we will further move on towards representing root x formation on a number line. Obviously, root x is nothing but representing any rational number over here or an irrational number over here. So it can be anything. So let us suppose we are just talking about representing root x on the number line. So let us suppose I just want to represent root x on the number line. So the steps that will be taken to represent root x on the number line would be like, let us suppose we are taking any particular line. Let us suppose we are calling it as A and B, and this distance AB is nothing but representing x, because we are plotting root x on the number line. So let us suppose I will take x on a number line. So let us suppose I am talking about taking AB distance, which is nothing but x. So let's just move on further. The second step would be like, we will take any 1 unit distance from the point B, any 1 unit distance from the point B, so that the BC will be nothing but of 1 unit. So the step number 1 was like, we will take any particular distance x, because we are talking about representing root x on the number line. So we will take any x distance, that is AB distance first of all, that is the step number 1, and after that we will take any 1 unit distance from the last point B towards the point C. So BC will be of 1 unit. So the next step would be like, take the midpoint of AC line segment. Take the midpoint of the line segment AC. Let us suppose the midpoint is nothing but the point O. So taking O as a center of AC, or the midpoint of AC, and OA and OC as the radius of a circle, draw a semicircle. So the next step would be like, taking O as a center, OA or either OC as a radius, draw a semicircle. The further step would be like, taking B as a point, draw a perpendicular BD, draw a perpendicular BD, which is nothing but perpendicular to AC. So BD is nothing but perpendicular to AC. So now we will prove that this distance BD is nothing but a square root x. So it represents square root x. So how it will represent square root x? Let's just move on, or let's just talk about that. So always remember all these kind of steps in order to represent root x on the number line. So first of all, I will write all those steps that I have taken in order to form this particular construction or this particular representation. So let's just start with it. First of all, we are talking about the steps that are taken over here. The steps would be like, the number 1, draw AB is equal to of x units. AB is equal to the x units, and extend B to C such that BC is equal to 1 units. Always remember to extend B towards C, and it is always of 1 units, not more than that, always of 1 units. Let's just talk about the second step. The second step will be like, find the midpoint of the line segment AC, say O, on the line, and taking it as a center, and OA is equal to OC as a radius, draw a semicircle. So the third point would be like, draw a perpendicular at point B to D such that BD is perpendicular to AC. So fourth point is BD is equal to root X, which is our desired result. So BD over here will be of root X units, which is our desired result. So how this BD is of root X units? So let us suppose, we'll discuss about it. Let us suppose I am joining O and D over here. So I am joining O and D over here. As we know that OBD over here is nothing but representing a right angle triangle. Just see, the triangle OBD is actually making a right angled triangle, which is the right angled one at the point B. So let us suppose I'm talking about OBD triangle. So let us suppose I'm taking OBD right angle triangle over here. I'm taking right angle triangle over here. So this is O, this is B, and this is D. So I have to prove that BD is nothing but root X. BD is nothing but root X units. So let us suppose we'll talk about the hypotenuse, the base, and the perpendicular. As we know that this is nothing but perpendicular, this is base, and this is hypotenuse. And as per the Pythagoras theorem, we know that OD's square is always equal to OB square plus of BD square. Why so? Because we know that hypotenuse square is always is equal to perpendicular square plus base square. This is Pythagoras theorem. H square is equal to P square plus of B square. This is Pythagoras theorem. Okay, so we just want to find out BD. So BD will be like, BD whole square will be like OD square minus OB square. Now let's just find out the values of OD and OB from this particular representation. We know that the value of OD, we just wanted to find out the value of the OD. As we know that OD is nothing but the radius of the circle, and radius will definitely be equal to OA and OC again. So if we can able to find out the value of the OC, that will definitely be equal to OD. So let's just talk about the OA or the OC value. As we know that the total distance from the point A towards the point C is nothing but x plus 1. So let us suppose I'm writing over here. As we know that the total distance AC is nothing but x plus 1. It is all clear to us. If the total distance from A to C is nothing but x plus 1, so AC is actually a diameter. Of this particular semicircle. So we just wanted to find out the radius of it. So radius is nothing but half of the diameter. Radius is nothing but half of the diameter. So diameter was AC. So AC by 2. What is the value of AC? AC is nothing but x plus 1 by 2. So AC is x plus 1 and divided by 2, so it will be x plus 1 divided by 2, so the radius is nothing but x plus 1 divided by 2, so the value of OD will be x plus 1 divided by 2. Hence the value of OD here is nothing but x plus 1 by 2. So substitute the value of OD over here. So OD is nothing but x plus 1 by 2's whole square minus of OB. Now we just wanted to find out the value of the OB. What is OB over here? So let's just talk about the distance OC first. Let's just talk about the distance O towards C first. So if we are talking about the distance OC, so let us suppose I am talking about the distance OC. Okay, so the distance OC is nothing but can be represented, OC can be represented as OB plus of BC. We can see from this particular representation that OC distance will definitely be equal to OB plus BC. Okay, then further we just wanted to find out the value of OB. So what is OB? OB will be like, after rearranging it, OB will be like OC minus of BC. What is the value of OC? What is the value of OC? OC is nothing but the radius whose value is nothing but x plus 1 by 2. So substitute the value of OC over here, which is x plus 1 by 2. So this is x plus 1 by 2 minus of BC. Minus of BC. What is the value of BC? BC is nothing but 1. So this is 1. Now solve it. So it will be like the LCM of 2 and 1 will be 2. So it is x plus 1 minus of 2. So this is nothing but x minus 1 by 2, because plus 1 minus 2 is nothing but minus 1. Hence OB is nothing but x minus 1 by 2. So substitute the value of OB in this particular equation. So OB's square will be like x minus 1 by 2 whole square. Now just solve this particular value. So BD's square will be equal to x plus 1 by 2 whole square minus x minus 1 by 2 whole square. So let us suppose I am expanding it as x plus 1 whole square divided by 2 square, which is 4, minus x minus 1 whole square divided by 2 square, which is nothing but 4. So after taking out the LCM of it, it will be 4. So it will be a plus b whole square. We can use the identity of a plus b whole square over here. A plus b whole square is nothing but a square plus b square plus 2ab, minus similarly a minus b's whole square identity we can apply over here. So this will be a square plus b square minus of 2ab. Now expand it further, so it will be like x square plus 1 plus 2x minus, when we will solve the negative of this particular bracket, so it will be like minus of x square plus minus minus of 1 minus minus is nothing but plus 2 of x divided by 4. So solve it now. X square and minus of x square are getting cancelled out. Along with it, plus 1 and minus 1 are getting cancelled out. So this will be nothing but 2x plus 2x, which is 4x divided by 4. So 4 and 4 get cancelled out. So at the end, we are getting the result as BD square is nothing but x. So it implies that BD is nothing but is equal to root of x. So hence, from this particular result, we get the answer as BD is nothing but representing root x. So this BD is nothing but actually representing a distance which is root of x. So it means that whenever we just want to represent root x on the number line, so these are the particular steps which we have to follow in order to represent root x kind of a number on the number line. So I hope this all concept about representing the root x on the number line is all clear to you, that what are the steps that are to be taken in order to plot root x on a number line.